All right, so we wrapped up the other day talking about regression from data and how to enter it and then to verify that a linear regression is appropriate. But there's a little bit more with that, which some of it's stuff that we've kind of done before and others of it's a little bit different. So once your data is entered, select, so this is just going to be the calculator function, stat calc for, which is going to be linreg in the form of ax plus b. And then you're going to do enter, and then it's going to ask you for an x list, which is going to be your L1, y list, which is going to be your L2, frequency list, we leave blank, and then we're going to store the regression equation with vars, y vars, function, and then y1, and then we calculate, and it'll put it there, and then it'll draw your line for you, all of that fun stuff. And then we ultimately, when we write your equation down, we write the equation as y hat is equal to ax plus b. Now, if you know specifically what the variables are, like in the example that we did back up here, where is it? We knew what the variables stood for, so we actually replaced them with those words. You would do this, you would want to do the same thing. But if you're just copying the equation down, or if it's just like for a generic set of numbers or something, you would just write it like this. So, how do we check if our model is appropriate? Look at the residual scatter plot. I did. I'll give them back to you when we're done with the notes.
That happens to me a lot, and then somebody like says something about it, and I'm like, oh my gosh, great.
I always think back to like, what did we do before grades were online?
Yeah, really though.
That's insane.
Also, none of us failed our English test.
Well, that's good. Sounded
Everybody's
like that was
freaking
a
out
great
about it.
concern.
Yeah, I mean, we all did fine.
That's insane.
All right, when you use your calculator, to complete a regression, or regression model, the calculator automatically fills in a list with the calculated residuals for each x value. View a scatter plot by graphing x and the residual or y and residual. So when you're looking at it, you want to see nothing of interest, just random scatter, any line, curve. I cannot write today, this is bad. Line, curve, or pattern in a residual scatter plot indicates that your linear model is not appropriate. So a few examples of this, of what we do and don't want. All right, so if you have something like
Whoa.
that, or that, we want this. Okay, one of these options. But if we have something like this, we don't want this. Okay, any kind of specific pattern we don't want, because that will tell us that our model is not appropriate. I always have to remember how to do these, but you can do these on your calculator too. I just always forget how to do it. But there is a way to, it's in your jacket. We can also check the appropriateness by looking at the R squared value. This value tells us the percent of our Y variation that is determined by the variation in the X variable. So for example, if we do a linear regression, so that's when you get out the equation and it gives you your A, your B, your R, and then it'll give you R squared. I think we fixed our calculator, so it did that the other day. And the output reads R squared is equal to 0.6107. We can state that 61.07% of the variability in Y, and we put it in the little like greater than, less than things. I don't really know why, it just is accounted for by the variability in X and then we can also say, if we do 100 minus the 61.07, which would be 38.93, we would say then that 38.93% of variability in Y is a result of other factors not in X.